Okay, so section 2.1, functions and their graphs. After this lesson, you need to be able to use correct vocabulary when describing functions, represent a relation using a table, a mapping, or a graph. You need to describe the domain and range of a function given a table, a graph, or a mapping. And then starting tomorrow, we're going to be using function notation, but again, we'll do that tomorrow. So we just need to be worrying about 1, 2, and 3 today. Okay, so relations. A relation in math is really just a set of ordered pairs. It's an input and an output. You tell me something, and then I tell you some information about whatever that input was. You can see here a table, and we have vehicle, boat, bicycle, motorcycle, car, van, truck, and then number of wheels. The vehicle is the input. You have to tell me what type of vehicle in order for me to tell you, well, how many wheels does it have? Now we have to be able to express relations in different ways. Okay, your boss, whenever you get to your job, may not be a table kind of person. So there's other ways of doing this. Okay, one way would be to make what's called a mapping. And so you could list the vehicle type in one column and the number of wheels in the other. So under vehicle type, I'm going to draw some pictures here because I love art. And then underneath the number of wheels, I'll write 0 through 22 because those are all my outputs. And then I'm just going to draw a line. The boat has 0 wheels, the bicycle has 2, the motorcycle has 2, the car has 4, and that van has 4. And then the truck has any of those numbers between 4 and 22. This is what we call a mapping because you are drawing basically a map line from the input to the output. Now there's some key vocab here that you need to know, and that's this. If it's an input value or an input vehicle or any type of input, that's what we call domain in math. They could have called it dog, but dog was already taken. An animal is a dog. But domain in math means the inputs, okay? The outputs are what we call range. And they could have called it anything. They could have called it cat if they wanted to, these mathematicians, whenever they made up these words. But they chose range, okay? So again, all the inputs, when you list them together, that's your domain. All the outputs, when you list them together, that's what we call range. Now, another way we can express a relation, and it's kind of how we define the relation, is as a set of ordered pairs. And remember, ordered pairs always go an input, then you put a comma, and you write the output. So for the first ordered pair, I look at my input, I see boat, and then the number of wheels is 0. Input, comma, output, boat, comma, 0. Bicycle, comma, 2. Input, comma, output. Motorcycle, comma, 2. Car, comma, 4. Van, comma, 4. And then this gets a little tedious. Truck, comma, 4. And then we have to keep on going. Truck, comma, 6, 8, and on down the road until we have no more outputs there. And this is what we call a set of ordered pairs. So right now, already, we know 3 different ways of expressing a relation. We've got a table up at the top, a mapping on the left, and a set of ordered pairs on the right-hand side. And again, your domain is the set of input values. And you can see that from the ordered pairs, you can see it from the table or from the mapping. Range is the output values. Now there's 2 different types of relations that we need to know about. Look at the top here, you'll see the big truck, and it's pointing to 4 wheels, it's pointing to 6 wheels, and it's pointing to 8 wheels. This is what we call a one-to-many relationship. The one input has many, many outputs. But look down at the bottom. You have car going to 4 wheels, truck going to 4 wheels, van going to 4 wheels. This is what we call one-to-one because each input has only one output. And if you read down at the bottom, it says a relation where each input has exactly one output. We give that a special name. It's called a function. So the bottom here is a function and the top is not. Now functions come up in everyday life. Okay, the relation in which the dollars earned by the Outback hostess is determined by the number of hours worked. That's one-to-one. Okay, how much you earned is determined by how many hours you work. Okay. So for example, if you work 1 hour as an Outback hostess, you might earn $5. 2 hours, you earn $10. 3 hours, you earn $15. You're not going to work 2 hours and then earn $10 and $12. It's 2 hours for your input, 1 output, $10 that you earn. Okay? This is what we call a function. Let's start using more numbers here. Redbox charges $5 to rent a video for a night. Redbox gives a $5 discount if 4 more videos are rented. Represent this relation using a table. I'm going to set this up. I want to know number of videos I'm renting and total cost. How is this related? Now we have to pick some numbers here. And so I'm thinking to myself, can I rent like negative videos? Do I have to take that into account? But no, we can't rent -1 videos. The least number of videos we can rent is 0. And so I'm going to fill in my table 0, and then I can rent 1 movie, 2 movies, 3 movies, 4 movies, 5 movies, 6 movies. I'm not going to rent 2.5 movies. I'm not going to rent -5 movies. We're starting at no movies and going on up. Now total cost. If we don't rent any movies, obviously we're not spending any money. If we rent 1, 5, we rent 2 is 10, 3 would be 15, but when you rent 4, remember you get a $5 discount. So typically 4 would be $20, but the $5 discount takes us back down to 15. If we rent 5 movies, it would cost us 25, take us back down to 20. 6 movies should have been 30, $5 discount, take us to 25. So here's this table, and here's what I want to do with it. Okay, I want to express this as a set of ordered pairs. So write down your ordered pairs. Remember, input comma output, 0 comma 0, 1 comma 5, 2 comma 10, 3 comma 15, 4 comma 15, 5 comma 20, and 6 comma 25. And then what we want to do is we want to graph the ordered pairs. Now notice I put number of videos along the horizontal axis, the x-axis. Okay, your input, number of videos in this case, always goes along that x-axis. Total cost being the output always goes along your y-axis. Now we also have to label our units here. The x-axis, notice we're going the input, we're going 0 videos, 1 videos, 2 videos, 3, 4, 5, 6, and I'm going to label it as such. But it wouldn't make sense to go by ones on the y-axis, because total cost in dollars goes 0, 5, 10, 15, 15, 20, 25. So we'll go by 5s on the y-axis. Now we're ready to plot some ordered pairs. 0, 0, 1, 5, 2, 10, 3, 15, 4, 15, 5, 20, and 6, 25. Now what I want you to think about here for tomorrow, and we'll go over this in class, is why am I not connecting these points with lines? Or should I connect them with a line? Okay, think about that, and we'll talk about it in class tomorrow. Okay, so getting into more kind of concrete math here, we want to represent the relation as a graph and a mapping. You're going to be expected to do this for your final exam. We're giving you ordered pairs. I want a graph and I want a mapping. In the last example, we started with a table, then you made the ordered pairs, then you made the graph. Here we're kind of starting a little bit, down the ladder. We're starting with the ordered pairs, so you need to graph those, and then you need to create a mapping. So go ahead and plot your points on your graph, and then see if you get it correct. So the blue, -2, -3, you're going to go left 2, down 3. Red, -1, 1, left 1, up 1. Green, 1, 3, right 1, up 3. Purple is 2, -2, right 2, down 2. And black, 3, 1, right 3, up 1. Now for the mapping, remember that's kind of like on that first slide we had the pictures of the boat, the bicycle. And so again, you're just looking at you're going to list all your input values, you're going to list all your output values, and then you're going to draw lines. So I like to make 2 circles, and then I'll write all my x values in the x circle. -2, -1, 1, 2, 3. And then my y values I'll list in the y circle. And you'll notice that I only have the 1 listed once. If you look up at your y values, we have -3, +1, 3, -2, and +1 again. But you only have to list it once. Because when you draw your arrows, -1 will be drawn to 1, but then 3 will be drawn to 1 also. So save yourself some ink, some pencil lead, whatever it may be, and just draw that y value once. This is another thing you're going to be expected to do. Start with a graph, and then write the ordered pairs in the mapping. So go ahead, write your ordered pairs down, create your mapping, and then see if you get it correct. So blue, -2, -1, red, -1, +2, green, 0, 1, purple, 1, -1, and black, 2, 2. The mapping, I think mapping is easier to do once you see the ordered pairs. I'm going to write all those x values, -2, -1, 0, 1, 2. I'm going to write all my y values. I'm not going to repeat the -1s. I notice the blue ordered pair has a -1 in the y, and the purple ordered pair also has -1 in the y. I'm not going to write that twice. And then we're drawing arrows. Okay, so going back to this word function that I used earlier. A function is a relation for which each input has exactly one output. Sometimes it's easier, though, to think about it in terms of what is not a function. And so if any input of a relation, any x value, has more than one output, more than one y value, that relation is not a function. So I'm going to put two mappings up here. You need to decide which is a function and which is not a function. Remember, if an x value has more than one y value, it is not a function. So look on the left-hand side. -3 only goes to 2. -1 only goes to 3. 2 only goes to -4. And 4 only goes to -4. On the right-hand side, so since on the left-hand side, -3 only goes to 2, -1 only goes to 3, 2 only goes to -4, and 4 only goes to -4, that is a function. Each of those inputs has exactly one output. But on the right-hand side, notice -2 goes to -4, but then the 1 in the x in the input column only goes to it goes to -1, but then it also goes to +2. So because of that, that's not a function. Now, this slide is kind of out of place here. It should be at the end or one before, but that's okay. Graphing equations in two variables, this is kind of like putting it all together in a way. We want to graph the equation y equals 2x minus 1. And what we need to do first is, I know most people know about slope-intercept form and everything like that, but when we get to things we need to graph and we don't know how, you can always make a table. And so we're going to come in here, and I'm going to choose some values surrounding 0. So for my inputs, I choose -1, 0, 1, 2. And then what you're going to do is you're going to plug, I don't like using the word plug, but substitute each of those x values into the x, and you're going to calculate some numbers here. And so we're going to get -3, -1, +1, and +3. And if you don't know how I got those numbers, you can ask me in class tomorrow. But for example, with the green, if I substitute 1 into x, we're going to have 2 times 1, which is 2, and then take away 1, you get 1 for the y. If I substitute the purple 2 in for x, you're going to have 2 times 2 is 4, take away 1 is 3. And then from there, we can plot our points. So here's -1, -3, 0, -1, 1, 1, and 2, 3, and then we draw a line through those. And think to yourself, why am I drawing a line through this one, but we didn't draw a line through the last one? And we'll talk about that. Alright, but going back to the vertical line test, and like I said, that last slide was a little out of place. How can you tell by looking at a graph if the picture you see is a function? Now remember, you're a function if each input has exactly one output. And so, as I said earlier, it's kind of easier to decide or look at what's not a function first. So look at the right-hand side. This is what we call the vertical line test. And if you run a vertical line over your graph and you hit the graph in more than one spot, okay, that means there's two outputs there, and that's not a function. So the right one is not a function. But if you take your vertical line and go over your graph and it doesn't hit in more than one spot, then that is a function. You'll notice that no matter where that vertical line was on this graph, it only hit the graph once. That means that is a function. So kind of a little hodgepodge of ideas today. We're going to talk about function notation tomorrow. Remember, write down any questions you have, and we can go over those in class. You can tweet me your questions, and we'll go over them in class tomorrow. In any case, I'll see you then.